Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is Ralph Squillace. Ralph is a principal program manager for Microsoft, helping the team supporting Helm, Draft, Brigade, CNAB, or is it CNAB? I don't know.
CNAB.
And Visual Studio Code Kubernetes extension in the cloud compute team. He's worked in distributed computing for many years. Welcome, Ralph.
Very nice to be here.
So, Ralph, before we get started and kind of dig into the meat of things, would you kind of give our listeners an introduction to yourself? Maybe sort of tell them how you got started in the industry?
Sure. And first of all, you also introduced this conversation is partly about clean code. So first of all, that part I'm going to skip. So outside of that, I can give an introduction. I actually have been in computing for a long time, distributed computing for a long time. You can see from the gray hair that that's true. Believe it or not, I did my graduate work in U.S. history and European intellectual history. And so in theory, I shouldn't be here, but I grew up. My father worked at Boeing Computer Services, and he would bring home, when I was very young, 8, 9, 10, he would bring home all the little home assembly kits, the early computers that were personal. And then he would give them to me and tell me, here's the manual, can you assemble them? And he would run off to dinner, and I would sit there and assemble the machine like it was a puzzle, like Legos or something. It never even occurred to me that was a useful pastime. It was just something that, well, Dad couldn't figure it out, so I guess I got to do it. And strangely enough, I went through life having built, repaired, written programs, the whole thing, without really thinking of it as a career. And I went to go be a professor of history and realized that was a bad idea at some point. And somebody said, hey, well, you've done computers wherever. This was like late 80s, early 90s. And somebody said, well, you can waltz in and do computers in there. This was Seattle. I was born and raised in Seattle. And it was a giant sucking sound in Redmond called Microsoft at that time. And they were like, well, they'll hire anybody who can walk. And at the time I was injured, so I limped a little bit, but I thought maybe I could do it. And sure enough, basically I just walked in and they said, well, can you write programs? Sure. And here's how computers work. And I was like, yeah, got it. And so once I started doing that, then I started focusing on various areas that were intellectually interesting. And so I'm one of those people that didn't go to get a CS degree and worked in computers as they were growing and helped participate in the shaping of a lot of technologies at Microsoft that from about 1995, say Windows 95 emergence, through about 2010, when we get to the beginning of the cloud, really, encompasses large chunks of Microsoft's both successes and massive fundamental failures. So it's been fun.
Sounds like it. So what are you sort of doing these days at Microsoft?
So these days I work in what is called, the names change depending on the reorg of the year. I work on the Azure Compute. They have an application platform team. And we report through Gabe Monroy, who was the former CTO of Deis. If people remember Deis, acquisition 3-4 years ago. And under Gabe, there's things like Azure Functions, which is one kind of app platform. There's messaging like Service Bus and Event Hub and things like this. And then there's also K8s, the Azure Kubernetes service, which is under. So those are different app platforms, if you will. And there's also upstream contributions. So I work on the upstream team. And our job there's two chunks of the upstream work. My job is to work on the developer and operational tooling for upstream. So that's Helm, although I'm not the Helm PM anymore. Bridget Pramod is my colleague. She's fantastic. That also involves things like Virtual Kubelet project, which is in the CNCF, and Brigade, which is in the CNCF. Then, of course, you mentioned the Cloud Native Application Bundles and Porter, which is a developer tool for that, which is in the Joint Development Foundation, which is a foundation of the Linux Foundation. So there's like foundations all the way down, right there.
Oh, perfect.
And then a really fantastic tool, the Visual Studio Kubernetes extension, which works on Kubernetes everywhere. It's not none of the work I do is related to anything proprietary at all. The other side of the team does app infrastructure, if you will. So they're the teams that do things like service mesh interface. They're the teams that did the gatekeeper work for Kubernetes and things like that, in addition to work we do upstream for things like Moby and container ecosystem, and also provider work. And that team also contributed the code for the new dual stack work that just recently released in Kubernetes. So IPv6 and IPv4 at the same time. So that kind of stuff gets done in my organization.
That's a lot of stuff.
And
That's really cool.
That's a lot of stuff.
Yeah, that's a lot.
I don't do all that. I have wonderful colleagues that are just much better than me, which is fantastic.
And before we started recording, you had mentioned that you're a Linux guy, and maybe if we've got some time at the end, we can talk about tabs versus spaces and line endings. But primarily, we're going to talk about Kubernetes. And Ash mentioned that maybe I was using something that's no longer cool, the K8s acronym. So maybe you can help clear that up for us. And
K8s.
Sure.
Kubernetes is a great word. I'm glad they used it. Makes it really easy to find when you do a search. But I think pretty much everybody in the ecosystem is Greek worded out at this point, and I think K8s is fine. K8s is fine. I'm not a big. I mean, anything you can hang your hat on. These are just branding names. I hate to break your bubble here, but it's fine. The only thing I don't like is kubectl.
Oh,
I think that was one John liked.
Yeah, I love kubectl. I heard, was it Fowler mentioned it?
I have a lot of colleagues that like it too. I just drives me nuts.
So you and I kind of traded tweets a while ago about kind of
we did.
Getting,
was that hostile?
Yeah, no, it was
okay.
Fairly tame.
I want to be professional.
It was more of a drinking from the fire hose as you threw documentation links at me, trying to put together
that's right.
a talk for .NET developers getting up to speed on Kubernetes. So maybe you can help us kind of walk through there, because there are so many tools available. There's Helm and Tiller and kubectl and all the things.
Tiller you can forget.
Yeah, and I had heard that recently as well. So
it really depends on where you are in your system. So like if you're the hardest space to be in, I think most of the Kubernetes ecosystem has figured out that there are 3, 4, 5 tools for assembling, packaging, deploying your work. Okay. And we'll get to those in a second. The real hardest area that is still, from one perspective, widely fragmented. From another perspective, there are lots of great choices. So it really depends on how you want to look at it. Is the actual developer iteration loop with Kubernetes. Because one of the great experiences in this world is the ability of, say, JavaScript to just, you just changed an index file and you reload it and it's there.
Mm-hmm.
That ease of reaction makes iterative development in JavaScript so easy. That you're willing to overlook all kinds of other intellectual problems with the language, for example. It just works, and it's so fast. The problem with introducing containers is that the native developer loop, which was basically in the Windows world was like an F5 loop, right, in Visual Studio. Mm-hmm. You'd have F5 and you're up and running in debug mode, and you can step through and set breakpoints and all this kind of stuff. And that's true from pretty much whether you're Windows or Linux or Mac, kind of thing. You'll be using different tools, but essentially the experience would be something similar. When containers were introduced, that idea was you were going to do your development and then spin up that same code in the container. And it turns out that for a brief moment, there were a couple of tools that sort of made it look like that was going to be possible. And one of them was one we initially started with 3 or 4 years ago called Draft. It was limited to a single service. So the idea was the experience was driven off the sort of Ruby metaphor, Ruby on Rails, where you just like did your thing. You said create, you got a project, you did your thing, and you said deploy, and it was there. You spawned the little URL. You could see the reaction right away. The idea was we could do it with Draft. This was the idea at the time. We could do it with Draft and have the same experience. And we sort of demonstrated it. We ended up not having all the resources to pursue all the project opportunities we had. Helm was really important, so we needed to work on Helm 3. We had cloud native application bundles coming. There were other upstream projects we needed to participate in and so forth. So we didn't really get it to optimize that project, but it sort of spawned a lot of other environments. And now you have several that try to treat that Ruby experience up, both on the Microsoft side. So things like Azure Dev Space, if you ever used them, they have this little kind of create, switch tool, or some of the other ones that we're releasing now, both as open source and not. There are these tools that are basically that kind of Ruby experience. So the influence of Ruby is really strong there. But also with projects that are in the outside the firewall ecosystem, that is in the broader Linux and container ecosystem in this world. So there's things like one of the ones that pretty much did the best job of kind of taking the Draft-like experience, Ruby experience, and then making it multi-service. And you got to get to a multi-service developer experience before you can get to real distributed applications the way that we intended them to be. Is something called Tilt. Tilt.dev is the URL. That's a good one to try. And that sort of lets you configure how you're going to build and operate, each individual service. It's sort of like you've got a make file there for each individual thing, but it has a coherent view of all the things at once. And so if it's configured correctly, it really can do a lot of wonderful things. So that's purely open source. If people know about it, they should try it out. But then there's that is sort of that kind of developer tool is from the perspective of people thinking that your scope, your mental state is I'm building microservices, distributed applications.
Right.
But in fact, there's another way to look at it, which is more natural to developers, which is a language-centric view. So like, for example, if I'm a Java person, for example, and I want to build something in Java or a .NET person or whatever, you're going to be thinking about all the tools you normally use in your native development. And so in that environment, you're almost certainly going to want to say, well, I want, I want my POM file. Like I need Maven to do all this bundling for me stuff. And what happened when you look at it from a language tooling perspective in developer, what you need to learn to do is figure out how to build your containers on the fly as part of your build routine, right? Part of your F5. The problem is that leaves container building as an exercise for a developer. And what we've discovered in about 3 to 5 years of containers is that at scale, most developers don't know and don't care how to build a proper container. I am not criticizing anybody here. From a developer standpoint, your code is the thing that you're optimizing. And although you could develop and test in the container running, the truth is to do that correctly requires you to master a lot of other details that have nothing to do. You become a container developer and not an application developer. Now that weird, what do you want to call it, hinge between native development and what is supposed to be immutable infrastructure, immutable applications, right? Means that you got to really sort of, from a developer language standpoint, you got to really nail the experience with your tooling. Individual developers love kind of geeking out on that, and it's wonderful. But what it means is that over the last 3 to 5 years, at scale, we've moved away from the container native development. We just failed to take things like Draft, and there were others. Like I say, Tilt gets close to this, and there are a couple other projects that are pretty good that we're trying. And since we failed to give that tooling enough work fast enough, basically developers and operational work went past. And now most people move to building the container on a push to Git. And that makes containment more of an integration solution, more of a CI/CD pipeline solution and less of a developer choice. That turns out to be the default. It's not necessarily the best or the worst way of doing it. It just, you can see that trend happening. The result of that, then that connect now makes it real easy to see why things like GitOps as a sort of flow, right, begin to be important, because now you can drive your whole engine of development and artifact creation and delivery off of what happens in Git, as opposed to what a developer might have done, right? It all sort of, you can see how it's evolved in a way that has to do with the developer reception and the inability to sort of, as a huge mass of talented people, sort of all skill up on container esoterica at speed. We really basically said, you know what, actually that's more trouble than it's worth. And so that's sort of where we stand now. It's actually, you go ahead and optimize on from a language standpoint, and choose your language, and then try and work with your surrounding environment to make sure that the tool for the language builds your containers correctly for debug and then also for release. Another problem with containers that's hard to get around is some languages can debug the same container that you ship, making things immutable there. But other languages, you got to actually put the debug container and run that, and that is slightly different than the real code. And so get into these, when you really start using this stuff heavily, you got to sort of be a master of that zone, which it's certainly doable. People are doing it, but what it means is in organizational situations, as opposed to, you know, smaller companies where they're closer to full stack, everybody's got to do everything kind of things. You end up looking at separation of concerns there, and somebody becomes an application operations team, and they work on the templates that developers consume and the pipelines that developers use, as opposed to the actual application. The developer does everything and happens all in one flow. So that's one of the things that I've always wanted to sort of just dump out in one place. It's an amazing, actually, process transformation where there were opportunities 2 years ago that we no longer have. Nobody's going to learn containers that well. As a result, one of the odd results of that is that containers are mostly way too big and heavy. This isn't like, I'm not even talking about Windows containers. Like, people ship containers with 800 megs or 2 gigs or whatever because they can. If they can, it takes more time to cut it down than it does to actually just ship a big container.
So very related to all of that, I have been using containers for development for a few years now. Started with a Angular application, and we needed it to run the same in dev as it would in production, because we were running into issues with Node being upgraded or not upgraded, and different versions.
Yeah, got to stop that.
Developers. Yeah, so so I built up the containers for that to work, so that we got a consistent environment all the time on everybody's computer. Solved a lot of problems.
Absolutely.
But well, and then in my newer applications, I'm doing Blazor, and I made sure to default to a containerized build. But in Visual Studio and just me doing it on my own, I've always used Docker Compose. Should like a developer, so like, I guess a developer in my situation where I'm the tech lead, so I'm the one responsible for making sure that the builds are good for development and can be deployed. I'm not to DevOps level of the CI and all that stuff, but I work with DevOps to make sure stuff works. So someone in my position, should I be doing Kubernetes? I don't even know. I know roughly what Kubernetes is, but I always kind of think of it as like this VLAN that has all the containers for your application. Not, whereas like, well, I guess I look at it as exactly the same thing that Compose kind of does. So that's a
fair view. So I also am of the, so first of all, you know, caveat, I love Kubernetes. It's a lot of fun. It's a great system. But it's a tool. Don't fetish your tools, ever. No, I can say that. I'm like, I'd like to laugh about it. I'm dead serious. Do not fetishize your tools. The reason being is because you can see I'm gray. So there are so many tools I have eaten, consumed, and how should we say this, processed in my life, that what I can tell you is tools are great when they serve your needs. And so my first question to you is, you don't need to use or know Kubernetes until, in fact, it slaps you in the face that you have to. So like, how do you build and deliver right now? Do you know where your DevOps team drops your container or your application? If they drop it on Kubernetes and you don't know, why do you even care?
Yeah, I think they're just doing a app service.
Okay. So whether it's app service, like we'll talk about Microsoft terms, or whether it's, anything else, right? Like it could be any paths, and you give them a container, or you give them a bundle of stuff, right? Maybe so for example, you describe using containers as a consistent development environment, right? So the entire dev team could be slightly wiry, or, and yet when they're inside that container, they're always getting exactly the right thing for delivery. Okay? So it doesn't even matter whether you're delivering the containers or not. The point is, your containers are already helping. That's great. That is a fantastic tool, and it continues to work well. The Kubernetes is very straightforward to understand. In fact, the details, of course, are complex because, orchestration is hard work. But it's basically taking the container you built the app in and then giving it to a Docker host and running one of those, and then wanting to run 10, and then wanting to run 1,000,000. So you got to build a program that runs 1,000,000. So Kubernetes runs 1,000,000 for you. And if it falls over, they'll replace it, and you don't have to do that. Okay. That is a fairly simple, very high level, obviously, description of what Kubernetes does. So your take on it is right. It is another way of looking at it is, if you've done Docker and you're familiar with Docker compose files, for example, a compose file is just another way of looking at, I've got 1, 2, 3 of these, I've got over here, and they connect in this way, and I'm good to go. Logically speaking, compose is a fantastic way to think of, from the developer standpoint, of a distributed application. It's basically services talking to services, and you can look at them and see how they interconnect and so forth. Kubernetes manifest is just a more complex version of that. And so, like, for example, if you get to Kubernetes, that's an implementation detail of what you're doing and looking at when you look at Compose. Compose is a great format, and I'm hoping we're going to see a lot more that uses that format coming forward.
And that's why I really appreciate that we have decided to kind of kick that responsibility down the road to the folks that are interested in maintaining and creating that infrastructure, virtual infrastructure for us in Kubernetes. That not every developer has to know all of it to be able to develop. We just have to know enough to maybe make sure it's containerized.
Yeah, that's absolutely true. I mean, as a developer, if you haven't gotten into Kubernetes yet explicitly, right? Like somebody didn't say, "Hey, here's money. You will now learn Kubernetes." If you're building processes, which is an app as a process, and especially if you think of like a web app, it's just an endpoint that serves HTML as opposed to or an API, things like this. If you're building one of those, right, keep building. You should not be distracted by Kubernetes. I can give you an example of why. Another story of the 5 years of Kubernetes history. And that is that one of the other things that happened is that originally Kubernetes was a very simplified but powerfully structured and powerfully flexible architecture to scale out individual processes where the processes were continuous, right? Okay, and there are lots of knobs inside Kubernetes that you can touch. And the thing about it is the delivery mechanism is not Compose. The delivery mechanism is this YAML ball or a JSON ball. Either way, it's got a whole crap ton. I think I can say crap ton. I think we can still call that professional language. I believe it's Latin. And if it's not, it should be. So it's got a whole crap ton of these various values that you're going to put in here. Almost like 1/10 of them seem like they're related to your app. Okay.
Yes. Yeah. Yeah.
And part of that is because there's a ton of it is repetitive, which is one of the reasons the Helm turns out to be a very useful project, because basically it abstracts out into a values file the only things you care about really setting switches on, and everything else is sort of some templated ball of mess, but you never have to see it mostly. And so it turns out that works. That's a very powerful model. to make things reusable and installable, and then abstracts out only the details about the app you really care about when you're using it. That said, ultimately that ball is for Kubernetes, and it confuses you. Mm-hmm. You look at it as a developer, if you haven't seen that before, it's a mess. And it's not intrinsically understandable. And early on, I think in the first 2, 3, 4 years of Kubernetes, a lot of people who were very excited about Kubernetes potential made the mistake of thinking that Kubernetes itself was the application platform. Kelsey Hightower, who's just wonderful, thinking about the different ways of looking at development and platforms, has this thing where it's like, I hope it was Kelsey who said it first, but I think it was, where it was like, this is not the platform, but the platform for the platform. And over the last 2 years, it's pretty clear that most people have understood that there is infrastructure applications that will be Kubernetes applications. A great example are service meshes, right? You're adding feature to or controllers, right? CRDs. You're adding complex programmatic functionality to Kubernetes, but your users are going to use an API that's much simpler. They don't have to actually know how you built the platform that they're going to consume. On the Microsoft side of things are things like Dapper or things like OAM, the rudder implementation. And like, I think there was an announcement we just did, David Fowler and the .NET core team did something like, what was it? I just announced something like TIE or something.
I missed that one.
I don't remember what it is. It's something, but they're doing something that's really, really interesting. Very, very similar, where it's like, you don't need to know all that stuff. Don't need to know all that stuff. So where we're at now is you should be thinking, somebody's going to give you a platform that looks like Ruby or something very straightforward that focuses on apps, and it just takes your stuff and it goes and stuff out the back end comes all those YAML files.
Yeah, and I've been trying to dive into more of the inner workings of Kubernetes and trying to get up to speed. And it seems like, and I think the progress has come a long way. It seems like it's still kind of early days, and there's still a lot of moving parts, and we're starting to see some of the complexity being abstracted away. Some of the tools are starting to be changed and modified. And I mentioned Helm and Tiller, and now we don't know or care about Tiller. And as those tools kind of grow, evolve, change, and become simpler to use and deal with, that's what's going to excite me. Are we getting closer to that point where it's starting to become more trivial to get up and running?
Trivial is a strong word. If you wish to deploy your app, build and deploy your app on Kubernetes, it's becoming much easier to do so. Kubernetes itself remains difficult. Not because you can't master it, but because, like complex computer things, when you sit down to really learn a system, it turns out it's hard, because software engineering at complex levels is hard. You just have to learn a lot before you sit there and go, oh, I get how this all fits together. So what you want to think about is, what do? Do you build apps for Kubernetes, or do you build operational apps for Kubernetes, or do you build applications? If you build applications, you should realize that you need to focus on things that deliver your app to Kubernetes. You don't focus on Kubernetes, because Kubernetes is going to be everywhere. It is it's the Linux kernel of the distributed container process world. It'll be there 10 years from now. It'll probably be there in some form 20 years from now for you to use. It'll look very different. And there's every chance that in 3 years, you won't ever ask the question whether you're using Kubernetes, because the thing you give your app to will be something else. So you should look for those something else's. My advice would be, look for something that says, I build this and you give that to Kubernetes and it works. Right? It's that kind of simplistic workflow that you're looking for. If you don't find one right now, you'll find one in 1 year to 2 years, and it's probably going to be supported by your favorite cloud provider. It need not be Azure. It can be Google, Amazon, DigitalOcean, OVH, Alibaba, whichever cloud you might be thinking will have it. Some great things still work from the onset of the PaaS Ruby on Rails still works. Mm-hmm. Why not use it? Heroku was a great platform. You can use it. These things are all the way you should think about using Kubernetes will be underneath these things that you get. So you should know you're going to end up being able to use Kubernetes without thinking that you right now have to use it. I hope that helps.
Absolutely.
Right. I think it should be an optimistic thing. Right. Kubernetes itself will go under a ton of change. So like in the beginning, Kubernetes was just this distributed container kernel, right? But there were a bunch of things that were missing in there. Like nobody bothered to do mutual TLS between services. Like what? Something I've had in native VM environments for 25 years, if not longer. And I don't have, like, it's not TLS. What? And we had to build service meshes for TLS, but we built service meshes to support TLS. Now we've got actually distributed tracing. We've got, debugging. We've got things like observability. We can do all kinds of fancy stuff with sort of time series sampling, almost real time, to detect very minute anomalies with AI looking at these error models in order to determine whether that's probably a problem or not. Nobody's expecting you to build all that. That's not your problem unless that's your job is to build one of those. In which case you're going to build one of those, right? And one of those is going to be a Kubernetes application. But most people will be building using it, but they're just going to be building Java or Ruby or Spring or .NET Core or Blazor or whatever it might be. Kubernetes is fantastic. It's great, but it's not required to be a genius and do fantastic work. One of the things that we did early on was at Microsoft was we put out virtual kubelet. Now, if you know Kubernetes at all at a high level, Kubernetes has this concept of a kubelet, which is representing, it's essentially the agent, the Kubernetes agent on a node. Mm-hmm. So a node is usually a VM, okay? But it need not be a VM. So Kubernetes just needs to know it's running or not running or whatever, right? So virtual kubelet means you could plug your node into something else. So on Azure, we connected it to Azure container instances, which is basically this, we run a container as a service thing. Mm-hmm. And that means you can just automatically add random containers to your cluster as virtual nodes, right? Without actually having modified your cluster, really. You just plugged in this kind of communicating kubelet, but it turns out the backing is not a VM from the perspective of reality, even though there are always servers somewhere, right?
So
now, go ahead.
With that kind of capability, and
you got me ranting here. I blame you. Go ahead.
just Kubernetes in general. Are there any new security concerns that we need to be aware of when we're using Kubernetes? Or does Kubernetes maybe even handle some standard security concerns that we no longer would need to worry about in that environment?
Should I laugh out loud and shame you, or should I just play it straight?
Please do.
I'm going to play it straight.
You can laugh.
No problem, John says. So it appears outside that I've got... unfortunately, ambulances. I hope everybody's fine in this day and age. We're not really sure. One sec.
Sounds close.
Oh, it's muted.
Yeah, I think he
did it on purpose. It was on purpose.
They're driving by the front road, so that's in this day and age, it's just sad.
Mm-hmm. Yeah.
Usually, not to get on to too much of a point, but we're all virtual for a reason right now. Mm-hmm. And I don't want to not acknowledge it. I hope everybody's okay.
Yeah.
All right, where were we? We were talking about trivial things like work and engineering.
You were going to laugh at me about security.
Oh, that's right, security. what were you thinking? Oh my goodness. Oh yeah. So and that's the laughter version. The straight version is actually you would like that to be the case, but sort of like the TLS. So I was talking about mutual TLS. Right, Kubernetes is literally an application that communicates between VMs and no more than that. So you shouldn't think of Kubernetes as this magic space whereby inside the Kubernetes, stuff that you used to have to handle yourself is handled automatically. That's actually not true at all. So they're just VMs with processes on them that are running in regular network space. So those VMs have to be hardened and access to them has to be, controlled. The network space has to be partitioned. There have to be failover VMs. There have to be roles to access those VMs. So underneath Kubernetes, you have to have an understanding of who can and cannot talk with those VMs. Mm-hmm. In raw Kubernetes, you can SSH into a node and do your little VM dance that we used to do, that artisanal I can fix it live dance, which you should never do in scale out architectures in any way, shape, or form. That is a broken anti-pattern. If you find yourself doing it, you should know you're doing it wrong and you should stop and figure out how to fix it. And in Kubernetes, you have to set those kinds of controls up. And in the end, that requires such deep Kubernetes knowledge that you are essentially in 97% of the cases going to run a distribution managed for you. This is why the cloud provider is going to work. This is why custom distributions that work on premise do the same thing for you. These are the reasons. You can do it. Don't get me wrong. There's nothing that is being done at the level of Kubernetes inside or outside that isn't just good old-fashioned sysadmin work, right? IT pro work. Right? Remember IT pro was going to go away? Yeah, well. So it changed. It looks different, but it is the same. So things like MTLS, you're going to have to install something inside Kubernetes that knows how to do MTLS. And it turns out you got to know a lot about Kubernetes to do that. That's just one example. And so there are many cases in which, in many scenarios in which it's actually easier to create a private subnet, run an entirely unprotected cluster in the subnet with one person that has 2FA to access that cluster and then just destroy it and rebuild it anytime you want. In many cases, that just happens to be simpler in terms of secure access and processing than doing the right thing. In most cases, however, the right thing is going to be working with some cloud vendor, cloud provider to set up a best practices system that works with the heavy integration with the cloud provider's security authentication systems, access, 2FA, rolling certs, the whole ball of wax. All of this stuff is very complex. And yes, you get to do it yourself. Congratulations.
Yeah.
So that's called job security, by the way.
So most of what we've talked about and relates to Kubernetes has been very much from a developer-centric point of view. What about sort of roll into those folks who are the maybe DevOps engineers or the application engineers, and they're looking to sort of build? You've mentioned Helm. We use Customize.
Yep.
What do you think about sort of the value of those particular applications, and why might you choose one over the other? Or are there other situations?
Yeah, so there's sort of three ways you can go at it. One is manifests, pure manifests. Manifests are basically API payloads, right? Like they're literally, you're looking at the values you're going to give the API. The upside of API values and working with manifests is that you know exactly what you're getting at all times. Then there's the rise of GitHub, GitOps, where the complexity of manifest file management just happens to be so great that it turns out to be useful that Git actually gives you a commit SHA and a distributed graph for every single commit. And so if you commit your manifests, well, then you can just check out and root and queue control apply to roll back, for example, and it gives you a lot of great confidence. So that idea is, in a way, kind of a compensation mechanism, but it's one that works, right? And so the one that's most often associated with that is Weaveworks Flux, right?
Okay. Yeah.
Which is a fantastic tool. We use it inside Microsoft, for example. Lots of people do, and that sort of epitomizes, the sort of GitOps workflow. But there are several other tools that do the GitOps workflow. You can build them yourself, which is because Git is relatively simple and so forth. So as a result, that's a very useful tool. But it's a tool for people who really do like the manifest, understand the API payloads and so forth. That works really well. Helm was sort of the original package manager for that. Helm took one step and said, hey, listen, one of the problems with this payload is actually most developers don't need to know all of this. In fact, most operators don't need to know all of this, because most of the values are not going to change from deployment to deployment. And it's so repetitive. The API payload is so repetitive that it's really easy to template out. Probably about 2/3 or even 3/4 of all the material in there doesn't ever change.
Yep.
And so Helm was an attempt to sort of build the kind of apt-get or yum of manifest, and allowed you to templatize things. So you can inject the same manifest every time and change one value, and then get some basic verbs like release management and things like that. And then allowed you to share an entire application working together with a kind of a very usable sort of administration model for that application. That was a tremendous step up for like the 80% case of application usage. If you were creating an application, you still had to understand the knobs and whistles and had to create a Helm chart, and that's no less or more complex than creating the manifest, right? You're still going to have to understand Kubernetes. But for usage, it's about 80% case. And the last time I looked at the most recent survey from CNCF, it's about 70% of the people responding to the thing say that they use Helm as their main deployment engine. But again, it's use case specific. It's if Helm helps you. If you get to a point where Helm doesn't help you, you shouldn't be using Helm. Never fetishize your tools. It doesn't mean that Helm's bad. It means Helm is not helping you. So Customize, for example, another attempt to sort of split the difference between templating and manifests versus charts. One of the things that bothered a lot of people with charts is that because Go was being developed and the ecosystem was Go, it was very, very easy to use, just kind of hijack Go templating engine to template in the Helm chart. So if you've looked at a Helm chart, if you're not familiar with Go, and you're thinking you're going to get YAML, you shall be disappointed. Right? And so there was always this idea that somehow somebody should rip out the templating or add other template types, template engines that were a little bit more comprehensible or something like this. And the real truth is that it wasn't as much of an effort you could have done it. It was always possible to replace it, add a templating engine to Helm that was not Go, and just nobody really did it. So it just, the template, in other words, clearly there were irritations with it, but it was good enough.
Yeah.
And it to this day, it remains good enough. Most people sit there and go, oh, okay, well, fine, I'll learn that template.
Yeah.
But there comes a time when other people have stepped up and said, you know what, I've got a middle way, right? And Customize is that middle way. It's somewhere between pure GitOps, templated manifests, and Helm charts, which are more packages with template. That happen to have manifest payloads in the end, right? All three are great tools, and you should use them all.
Awesome.
Quite seriously, you should feel comfortable using these tools. If they accelerate your world, you're using the right tool. If they provide you some sense of cognitive dissonance, this is just a little too painful, then you should probably investigate one of the others. And that's the way it should work as an engineer.
And I think your explanation, sort of the differences and the nuances, helps you make that decision in a good way, right? Like you shouldn't, you have to be able to know what you're moving to or reasons that there's something else available. Otherwise, you may just need to suck it up and deal with those things.
I have my own. Different. Yeah, you're absolutely correct. I have my own example. So we've implemented the spec called the Cloud Native Application Bundles, and we've been working on this with a number of other community partners for over a year. And it's the 1.0 core spec is out. We're going to conclude the security and registry specs this month probably, and I'm really looking forward to that. The interesting thing about Cloud Native Application Bundles is it takes the idea that there's not just Kubernetes. There are any number of runtimes. So there's Kubernetes, but there's also your Cloudflare DNS. Mm-hmm. Or there's your Azure DNS, but you've got a bunch of bash scripts that are installing stuff, and or Terraform and not Azure ARM templates, right? Like our world is heterogeneous now. Mm-hmm. Now Kubernetes is going to be a huge workload, but it's not going to be every workload, and your deployment chains are going to be more complex. If I buy your deployment chain today, I become rich and I buy Clayton's, entire business, and all of a sudden I'm not going to be able to get his productivity and force a new system on him. Mm-hmm. I got two systems. So how do I make two systems work? And while I spend the time, making use of Clayton and then disposing him like a desiccated Hulk on the sidewalk,
Wouldn't be the first time.
So like in that environment, we built a way to take and put an entire deployment pipeline and the application artifacts inside one container and structure that with a specification such that any tool that complies with the specification knows how to execute it for installation, deployment, upgrade, or uninstall, and custom verbs as well. The thing about that is people ask immediately, like, well, why would I use that if I'm on Kubernetes? And the answer is, you might not. Mm-hmm. Why would you use extra tooling if your tooling is working for you? Yep. And the answer is you only would use CNAB when you realize there's a benefit to doing so that helps some other pain point that is not your deployment to Kubernetes, because that's working fine.
And or your resume, if you're a resume distributed or a resume driven developer, then you could just use those toolings to expand their resume.
Just expand their resume, which I'm not going to deny people. Learning is always good. But realistically, I think it's important to realize these tools should be used only when they add value to you and not until then.
All right. Sort of in wrapping up, is there any resources that you might direct people to if they're like looking to get started into Kubernetes or Helm or any of these tools that we talked about? Where would you kind of point them?
Well, so I would say there's kind of two or three groups. So if you're interested in Kubernetes, you go read the Kubernetes docs for sure. The docs are really, really good, especially at the high conceptual level. You understand what's going on. You should also keep in mind that you do not necessarily have to implement Kubernetes yourself. And so that's important to remember. And so if you're not going to implement Kubernetes yourself, but you're going to use it, I would go read the documentation from your distribution. If you're in a cloud provider, the cloud providers, all big or small, all have great information about how to make use of their distribution, most of which is Kubernetes, but the rest of which is going to be getting you accelerated to use the features properly on the distribution that you're going to choose to use. And then in the same vein, I would also focus on your developer environment. Early on, most developers used Minikube. Minikube was a little bit awkward, very wonky. It's gotten much better, don't get me wrong. And so Minikube is one way to do it. I strongly recommend investigating using something from Rancher called K8s. I like it. It's open source. It's nice and small. It's very fast, and it is Kubernetes compliant. Basically, among other things, I don't want to get Darren all mad at me for saying too many incorrect things, but let me make something up now. No, among the things is he just jettisoned all the early Kubernetes APIs because they're just not used anymore. You want to use the most recent stuff. And so it's the kind of mainline Kubernetes conformance. And so that cuts down the size, and your ability to use it locally is dramatically increased. So that's one. Another one, which is fantastic, which we use in the VS Code Kubernetes extension, we have a provider for it, is called Kind Kubernetes and Docker. And that is probably the one to sort of really spin up locally and start using as a developer, because it's just a container. You can start it and you go to town. So that's Kubernetes stuff. Then there's deployments. You need customize. You might investigate Scaffold from the Google folks. You definitely need to investigate Helm. Helm is a CNCF a project, and it's tried and true. As I said, probably somewhere between 60 and 70% of most deployments are using Helm, which means the ecosystem is huge. The help you can get in the community is massive, and almost every system supports its use, including GitOps and Flux as a Helm operator you can use for that, for example. You go to helm.sh, that'll get you started. If you're into CI/CDs, you definitely want to investigate all the GitHub actions that help you work with containers and Helm charts. And if you're into GitOps, you definitely want to look at things like Flux, which FLUX, which you can get good demos for, and examples and docs are great on that side. Now, pure development, I would investigate the developer environment for your language, and see how they build containers and how they can create charts for you. Often languages don't create charts, they just create containers. So then you need something that does service composition for you as a developer. And like I say, I really like Tilt. It's a very good one. There's a couple others in the CNCF that are also good that I haven't used, so I can't really go about them too much.
Sure.
But also things like the work that various pipelines do. Things like Scaffold does sort of a developer iteration thing. It's not really, but it's close. As long as it works for you, that's great. And then your developer, your provider developer environments as well. Things like in Azure, you need dev spaces and various other things.
Okay.
That's the way I would break it down. And it helps you target yourself to take steps in categories. Sure.
Okay. If our listeners wanted to sort of follow you or reach out to you and in any way, what is there social media? What would be the best way for them to do that?
People are free to harass me on Twitter, which is my first name _ last name. So Ralph _ Squillace, which could be spelled any way you actually care to. But you can also email me at firstname.lastname@microsoft.com. That's fine too. The great thing with digital messages is you can press delete if you really have to. But I like hearing with people. I like hearing people and talking with them. So there it is. I do want to apologize. I did a lot of talking today, but you really launched me.
It was all really good. Yeah.
So I'm going to sit here and blame you three. But I hope something was useful.
Absolutely. Yeah, no, it was great. Yeah, thanks, Ralph. Really appreciate you coming on the show. Unfortunately, we didn't have enough time to talk about tabs and spaces and line endings, so maybe we can have you back sometime.
I will tolerate it.
That was Ralph Squillace. Ralph is a principal program manager for Microsoft, helping the team supporting Helm, Draft, Brigade, CNAB, and the Visual Studio Code Kubernetes extension in the cloud compute team. He's worked in distributed computing for many years.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.